Welcome to 3-4 Day 3. Are you ready to do some math? This will be a shorter video, just a couple examples and a couple problems for you to try. Some of the more weightier stuff, maybe. Solve this log equation. So we got 2 log base 5s of 3x equal to 4. And again, I'm going to underline my variable term, log base 5 of 3x. So we got to get rid of this 2. We could move it up and make it a 3x quantity squared, but that would give us a 9x squared, and why deal with a squared term? Let's divide both sides by 2. So now we've got it down to log base 5 of 3x is equal to 4 divided by 2 is 2. So now on the left side, we've got it down to a single log base 5. So we're going to exponentiate. Give this a base 5, give the other side a base 5. So the 5 of log base 5, that's going to cancel and turn into just a 3x, and that's equal to 5 squared. 5 squared is 25. Divide both sides by 3, and you get 25 thirds. And I believe, yeah, the book just leaves their answer like that. We could get a repeating decimal. 25 thirds is much nicer. So there we solved, what was that again? A logarithmic equation. Here's a practice one for you to try. Steps will be very similar, so give it a shot. Pause the video. All right, I would begin divide both sides by 3. So now we've got a log base 4 of 6x equals 9 divided by 3 is 3. And to get rid of the log base 4, we're going to give it a 4th power base, or a base 4 exponential. So the 4 log 4 cancels. 6x equals 4 cubed is 64. And we're going to divide both sides by 6, so that'll be 64 sixths. And I notice they're both even numbers, so I'll at least chop them in half. 32 thirds is a little better fraction, and that won't reduce anymore. All right. Example 9, checking for an extraneous solution. And I'll try to remember to point out exactly when we might introduce the extraneous solution. So let's see what we got here. On each side of the equals, well, on the right side we got a 2. Over here we've got a couple logs added together, a log plus a log, so we can condense these. A log plus a log, well, that's going to turn into a log of a product. And what are we going to be multiplying together? Well, the 5x and the x minus 1. And that's equal to 2. Okay, and remember, when you don't see a base number on your log, it's a common log, or base 10. So I can give these each side a base 10. So the 10 to the log base 10 cancels. And when I bring this down, I'm going to distribute the 5x right now. So that'll be what? 5x squared minus 5x. And that's equal to 10 squared is 100. This is the step right here where we may have introduced an extraneous solution. When we exponentiated both sides, it's possible a bad answer sort of snuck in. Okay. Well, before we factor things, we do like to have them set equal to 0. So I would subtract, the 100. 5x squared minus 5x minus 100 is equal to 0. And then I notice all my coefficients are multiples of 5. So I'm going to divide everything by a 5. That'll make my factoring easier. So what we now have is x squared minus x minus 20 is equal to 0. Whoa, I didn't mean to erase that. There we go. There we go. Okay. We need two numbers that multiply to negative 20, add up to negative 1. Of course, 20 is 1 times 20, 2 times 10, 4 times 5. There we go. Because it's minus minus, we know the signs will be different. We do want two numbers that are only 1 apart on the number line, and that's 4 and 5. So note, we know we've got an x and a 4 and a 5. We want them to add up to a negative, so that means the bigger number will be negative, the smaller number will be positive. All right, and when we set each of these factors to 0, we're going to get x is negative 4, x is positive 5. Let's check in the original equation. Okay. So here's where we're concerned. We're logging a 5x and an x minus 1. If I plug the 5 in there, 5 times 5 is 25, no harm done. Plug the 5 in there, 5 minus 1 is 4, it's positive, it's all good. Negative 4. If I put the negative 4 in there, I would be logging a negative 20. And you can't log a negative. That right there is enough to blow up that answer. It's extraneous. We would also see if we plugged it into the next one, that would be the log of negative 4 minus 1. So that would be a log of a negative 5. So either way, we've just disqualified that answer. It is extraneous. It was introduced. Whoa. It was introduced when we exponentiated each side. So here's the grand finale. Give this one a try and see if you can find an extraneous solution. I hope you get it right. Okay, left side, log plus log. We will have the log of a product. And it's going to be the multiplication of x times x minus 9. Let's distribute that right now and get x squared minus 9x. Why not? And that's equal to 1. All right, this is a common log, so we can base 10 each side now. Here is where we might be introducing an extraneous solution. The 10 to the log base 10 cancels. X squared minus 9x equals positive 10. So let's minus 10 from each side, and now it is equal to 0. Two numbers that multiply to negative 10 add up to negative 9. Minus 10 plus 1. All right, if we set those factors separately equal to 0, we will get x is negative 1 and positive 10. All right, if I plug the negative 1 in for that x right there, that's enough to stop. We would blow up this answer, extraneous. We could plug the 10 in there. We could log a 10, no problem. We could log a 10 minus 9. That's still positive. That's fine. All right, I think the show is over. We'll do some odd problems in class for practice, and that'll get you ready for the WebAssign, and then you're going to be a log and exponential solvent expert. I will see you in class.